Alright, I'm going to talk about how to collect data and to enter your data for the Spring Lab we're working on. So the first thing you're going to do is you're going to make a new spreadsheet or a new Google Sheet, and you're going to rename it. And so we're going to call this one, so we're going to name it after the class period we're in, and we'll do student name 1, student name 2, and then we're going to call it the Spring Lab. Okay, and then you're going to come over here and you click the share button, and you're going to type in the email address for your partner and click done so they can be a part of it. Later I'm going to ask you to actually share this spreadsheet with me, and the way you're going to do that is by getting a shareable link, and you're going to set it so that you're going to click more so that anyone with the link can view it, and you'll save that, and then you'll copy that link and submit it where I ask you to. Okay, so in the meantime, when we enter our data, what we want is to be able to paste into Desmos a row for the amount of force, or the amount the spring is stretched in meters, and the amount of force on the spring in newtons. Okay, and so, the amount it's stretched in meters and the amount of force in newtons. We'll say this. Now, this value right here, both these values, you have to do some calculations to get them. So for this one, you're going to want to measure, like when you're measuring lengths, you're going to want to measure the length in centimeters and get as much precision as you can, because here in this lab, the more precise your data and the more precision you have with your data, the better predictions you're going to be able to make. Okay. And this we have to calculate given based on the masses we're hanging. Okay, and so since both these are calculated values, we can actually have the spreadsheet find them for us. Okay, and so we're going to actually make a bunch more columns. Now, I'll tell you this. If you want to just do the calculations by hand and put them in here, you can. But as I said, it can be easier than that. So like, we'll record the amount of mass that we're hanging. If you want to record that in grams, you can. Later, we'll convert that to kilograms. Okay. Then we have the unstretched length of the spring. So however long the spring is when it's hanging. And we'll say, that could be in meters or centimeters, however you want to do that. We'll say centimeters. We'll say the stretched length. Okay, that would be in centimeters too. And then we can find the total amount of stretch in centimeters. So I'll walk you through what these things are in a second. And then we have extra row here. And this is really everything we need. Now I'll walk you through how we can fill in this table in just a second. But first we'll kind of illustrate what's going on. Okay, so you're going to have a ring stand set up with a ring on it. And then if we run out, you can actually share a ring stand with someone else. You can put 2 rings on it. But so you'll have a spring hanging on it. And then we want to figure out for each mass how much the spring stretches. We want this distance right here, the amount of stretch. So if we have measured the unstretched length and we've measured the stretched length, we'll call this one U and this one S. If we take the stretched length and subtract the unstretched length, that will tell us how much it stretches. And that's really all we need. So if we can record the amount of mass, we can calculate what the force is on it. If we record the unstretched and stretched length, we can subtract those to get the amount of stretch. And that's really all we need to take our data. Okay, from there, we're going to use the best fit line. And so you notice in the last one, we used W and M. Okay. For this one, we're going to use F for the amount of force and X for the amount of stretch. Also, this letter right here, instead of using M for that, we're going to use K for that. And the reason why is just that's traditionally what the letters used when we're talking about springs. When we're talking about the strength of a spring, we use the letter K. Okay, so as you're taking your data, it's going to be up to you what intervals you want to use for mass. But let's say that we went in intervals of 15. Let's say I started with 100 grams, and then I went to 115, and then 130. So right now my goal is to really just communicate to you some of the tricks and time-saving things we can do with that spreadsheet. Well, if I have a pattern here, and I select it, I can click in this little blue box here. You see how the cursor changes? I can click there and drag it down, and it's going to carry out that pattern as long as I tell it to. Okay, it'll do it for that pattern. It'll do it if I'm going by 20s. Okay, it's whatever it is, it's going to carry out that pattern. Okay, and then here, I want to actually convert this to kilograms. And so there's 1,000 grams in a kilogram, so I have to divide this number right here by 1,000. And so I can have the spreadsheet do that for me. So I can say, whenever I want to do a calculation, I put the equals sign. And so what I want to do is I want to take this value and divide by 1,000. So I'm going to click here, and then I'm going to divide by 1,000. Okay, and it does it for me. And now the thing that's really useful is we can actually copy the formula down as well. Okay, and it's going to convert all of them. Now if you see right here in this one, if I select it, you see it's referencing this row directly to the left, just like it did with that one right there. And so all I did was, after I typed in the formula, I selected in the corner and dragged it to paste it down. Okay, and the next thing, let's say the unstretched length of our spring is 45.3 centimeters. Okay, well, that's going to be the same the whole time, so I could drag that down. Now this one right here, it's not like we're going to go ahead and measure like 48.7, 49.6, 52.4. We can't do like that and drag it down. Okay, the reason why is because this is data that we're entering manually, and this is the part where you're actually trying to take the measurements. Okay, so it's important that you take an individual measurement for each value. Okay, if you do this and you drag it like that, like we did with the other stuff, the reason I'm telling you this is because I've had students do that before, and it really messed up their data, and they weren't able to participate in the rest. So when you're taking your data, when you're measuring how long the spring is when it's stretched, so like maybe with 20 grams it stretches 3.5 centimeters. Okay, when you're measuring this, make sure you measure it as precisely as you can, and make sure you measure one length for each mass you have on there. Okay, now I went by 20s here. You won't be able to go by 20s like this. It's up to you to decide what range you want to do. Anyway, continuing on, if we want to find the amount of stretch, well then we're going to have to subtract the stretch length minus the unstretched length. So we can say equals and click this one, and then put minus and then click that one. Okay, and then we get 3.4, and we drag it down, and it'll do it for all of them, including these ones as we fill them in. So let's say this one was 60, or we'll say 56.8. We'll see that it updates that as we go. Okay, we can convert it here to meters, and so for this one we would convert our amount of stretch to meters, and for this one we're going to convert the amount of mass in kilograms. It's not a conversion, I apologize. We're going to calculate the amount of force given the amount of mass. Okay, I'm going to have you do these last two calculations on your own, though. I'm not going to do those for you. Once you have done them, though, you can copy it like this. You do Control-C, and you'll open up a window as Desvos and press Control-V to paste it there.